In this video, I'm going to talk to you about interpreting two-dimensional and three-dimensional drawings or representations of shapes. And the reason I do this is because I give you a drawing exercise to draw some or to model some shapes, such as this one here. I give it to you in 3 dimensions, and hopefully you're able to work out what the shape looks like and pull it into the correct shape. The dimensions here are given as variables, and I'll give you a separate sheet so that you work out what sizes this all needs to be done. But the problem with this drawing is it doesn't necessarily show all the detail. We can see up at the top here, this is an L-shaped piece and we think it's been extruded up. And we have a block coming out over here on the left. But what we don't know is whether there's anything hiding behind the bottom. We don't know whether this missing section out of the rectangle here goes all the way to the bottom or if it only goes halfway down. To help you understand that, I show it to you not only in 3 dimensions, but I give you this drawing here which shows you the same shape in 2 dimensions as seen from 3 directions. I show it to you looking down from the top, I show it to you looking at it from the front, and I show it to you looking at it from the right hand side. The right hand side again doesn't show the detail of what's happening here, so the only thing we can see here is this shape here is a solid shape, and we can see, because we have gaps here, although we have dimension lines, we can see that there is nothing behind there indeed. So I'm going to go through this process of understanding how to read a 2-dimensional drawing compared to a 3-dimensional drawing, and we're going to do this using a different shape and a different set of examples. So let's switch across to this now. I've got a little shape here, and it's just a rectangular prism, and I've taken another rectangular prism out of it. So basically it's got a bottom, a side, and a back. It's not quite a sofa. If it was a sofa, it'd have another side over there. And I'm looking at it in 3 dimensions, and what I want you to notice here is that we have axes shown. So we have the blue axis, the red axis, and the green axis, and I want you to think about what the shape would look like if you were looking at it along these axes. So if you were standing over here looking along the green axis, and if all those green lines were perfectly parallel, what would you see? And the answer is that you'd only see this surface over here and this surface over here. So these are what we are showing here as visible from the green axis. If we stepped around and had a look from here and looked in this direction, we would only see this surface here and this one here. Whereas if I look down on the blue axis, I would see this one here and this one here. And I'm going to show you by coloring it in. Once again, if I'm over here on the green, looking along the green axis, I'll only see the green surfaces. If I'm over here looking along the red axis, parallel to the red axis, I'll only see the red surfaces. These surfaces aren't visible because the lines are coming out in parallel and I can't see them. Looking down the blue axis, I can only see these blue surfaces. So what would that look like if I drew that just in 2 dimensions rather than 3 dimensions? And the answer is it would look like 3 separate drawings, and they would look something like this. So when I'm looking along from the green axis, I can see these 2 green surfaces and nothing else. The red surface is partly here, this one here is the pink, and the red surface is there. That light blue surface is there, and the dark blue surface is up there. I cannot see it because the lines are all coming perfectly perpendicular out of the screen at me, and that these lines here are just essentially a knife edge in thickness. They're just the thickness of the actual color. So when I look down from the top of it, I can see that light blue surface which is along here, and I can see the dark blue surface which is along there, and here's the light blue surface and here's the dark blue surface. This is it looking along from the red side, along the red axis, and I can see these 2 red parts, and as I said, my red axis is here, red surface is here. This is the L-shaped surface. It goes down and across, it comes down and out the page, and this little pink surface is sitting over here. It's on this line and hidden by that line there. So that's what that shape looks like in 2 dimensions from the 3 different perspectives of the axes, okay? And every one of these is at 90 degrees from each other. So we have got a series of drawings that show you what it looks like from the left, what it looks like from the front, what it looks like from the top. And it's not an accident that we have the left here, the front, and the top. This is a method of doing what's called an orthogonal or 2-dimensional drawing, and this is called a third angle projection, and you don't need to know that. It's just a useless bit of information for today. But this is what it's going to look like if you look at these perspectives or these projections in 2 dimensions only. Now the catch is I'm not always going to give it to you nicely colored, and in that case what it's going to look like is that. Same drawing, same axes. What you need to be able to do is interpret that these surfaces match up. So if I come from here back to this one, you can see this little L-shaped surface and this little rectangle here while I'm looking along the red axis. So this is my left. I've got an L-shaped surface and a square, and that's what I have. I have this L-shaped surface and I have this square here. When I come back here, again I have this L shape that's coming across and down here on the right, and I have a rectangle there. And when I look at the top, I have this coming down on the right hand side, and I have a rectangle there. When I have a look at the front, I've got this L sitting on its shape where the short end of the L goes upwards, and I have a rectangular surface, and I can see the same thing there and there. And this is how you manipulate and understand the drawings from one side to the other. Now when you actually go to do the exercise, I am going to make it a little more complicated again, or a little more difficult to see things perhaps, because what I'm going to do is I'm going to add dimensions. So this helps you to understand overall sizes, and sometimes that can help you to match a two-dimensional projection against the three-dimensional projection, because if you can match up this 100 millimeters and this 50 millimeters, you know you're looking at it in that direction. And I'm going to show you through how that works through. So first thing I'm going to do is I'm going to take this, I'm going to switch it back into color. So we have that same drawing here. We have our color. I'm going to show you what that looks like in color. Here we have 100 millimeters and 50 millimeters. Here we have 160 millimeters. So this cannot be, here we have our 60. So when I have 150, I must be looking at the green surface. All right, and that can help you understand which projection you're looking at this from. And then if I take the color away, it's going to look like that. Now, one thing to be aware of, those clashed unfortunately. One thing to be aware of is that I have got every dimension on these that you need. Very often I will not give you as many dimensions as this. It is often adequate for me to say 100 millimeters and 20 millimeters, and you can calculate the 80 millimeters as you wish. So you won't always get as many dimensions as you're seeing here. But this is the idea of how you match up your drawings here. They will be labeled, shouldn't be a clash, showing the difference here between your surfaces when you look down from the top, and that means you're looking along the blue axis. When you're looking at it from the front, which means you're looking along the green axis, and when you're looking at it from the left in this case, you're looking along the right axis, and that's where you see these colors come into play. These are the colors that have matched up. So hopefully that helps you to understand. Now before I finish, this is a simple enough shape. There was nothing hidden around there, but if there was something sticking out the back there that isn't visible over here, then it would show up. I hope you understand. It would show up on this view, and it would show up on my left view, but it wouldn't show up on my front because it's hiding at the back there like that. So try to understand what you're looking at from the different perspectives and where things come about, and then just remember to keep manipulating the shape around to match up wherever it wants. It's useful to be able to use this and look straight down. You can use your tool in SketchUp, your view tool in SketchUp, to look at it from front, left, top, whatever, and try to match to the orthogonal views. When those orthogonal views look similar, then you know you have your drawing correct. So hopefully that helps you understand how to mix and match between 2- and 3-dimensional projections. I may have confused you further, or I may have clarified something. I'm not entirely sure which. Please talk to me in class if you need more explanation than this. Thank you.